All right, thanks, Luana, and thanks, Noko, for hosting this webinar. James Collier, Federal Highway Administration, and glad to have everyone on the webinar today. We're going to be talking about crowdsourced data for arterial operations, and this is part of our Everyday Counts Round 6 innovation on crowdsourcing for advancing operations. Let's go to the next slide, please. So just a quick disclaimer. So we're going to be talking about a few vendor products today. The reason we're talking about them is just because they're important to the objectives and purposes of today's topic. Doesn't mean that they're to be taken as a preference or approval or endorsement of any one product or entity by Federal Highway Administration. So here's our agenda today. I'll give a couple quick updates on the FHWA crowdsourcing initiative. And then we've got three great speakers lined up. We got the New Jersey DOT talking about real-time arterial monitoring and management. And then we've got talk about the Lafayette storm mode program and how it accelerates arterial resiliency. And then we wrap up with presentation from City of Austin on improving arterial operations using crowdsourced data and analytics. And then we'll wrap up with the Q&A. So please, if you think of questions, put them in the chat pod or Q&A screen. So I mentioned I'm James Collier. I'm one of the co-leads of the EDC 6 crowdsourcing for advancing operations initiative, and I work for the FHWA Office of Operations. And we've got some great presenters today. Kelly McVeigh, Principal Engineer from the New Jersey DOT. Ashley Moran and Hunter Fontenot from the Acadiana Planning Commission. And wrapping up, Allison Ritchie from City of Austin, Kimley Horn. And also helping Allyson will be Sean Quayle from INRIX. So I'll give a little bit more introduction about them each before their presentations. So if you've attended one of our webinars before, you know about the Everyday Counts or EDC program. It's really based on helping to rapidly deploy proven yet underutilized innovations. And these innovations are selected to help advance a number of objectives for agencies, shorten project delivery, enhancing roadway safety, reducing traffic congestion, and integrating automation. And I would say with our crowdsourcing for operations initiative, we're definitely helping agencies reduce traffic congestion and enhance roadway safety, those two objectives specifically. Next slide here. So why crowdsourcing for operations and why is it part of the EDC program? There's really three reasons why an agency would be interested in using crowdsourced data for advancing operations. First of all, it improves operational capabilities, helps to fill in gaps that agencies have in their monitoring equipment for better real-time situational awareness. And this allows agencies to more proactively implement operation strategies. Another benefit is it increases safety and helps travel reliability. One such example is crowdsourced data can help you detect incidents more quickly, which can in turn help prevent secondary collisions and reduce the amount of non-recurring congestion and improve reliability for travelers. And then the third benefit is it can really save costs for agencies. Crowdsourced data is efficient, is cost effective. It doesn't require as much upfront costs or maintenance costs as a lot of ITS infrastructure can over time. So here's some of the reasons why you might be interested in pursuing crowdsourced data. You've probably heard this before, but there's many different types of crowdsourced data out there. We'll be talking about a few of these today, but there's some of the varieties are vehicle probe data, navigation app data, social media data, connected vehicle data is an emerging source of data that's exciting. Many agencies have their own 511 apps or 311 apps where they can get information directly from motorists in real time. And then multimodal probe data is also kind of an emerging area, going beyond just vehicle data, but getting bicycle and pet data as well. Um, so crowdsourced data can be applied to many different applications within the realm of transportation systems management and operations. Here's a few examples that can improve traffic incident management. And we've seen a lot of states improve in this area. It can be used in an archive manner for traffic studies. It can be used for road weather management. Traveler information is another big one, kind of a low-hanging fruit. A lot of agencies are using crowdsourced data for populating their 511 systems, using travel times on dynamic message signs and things like that. Performance management is really useful for using archive data for better performance monitoring. And then arterial management is the topic we'll be talking about today in detail. Just a few other areas, but the bottom line is really anything within the realm of transportation operations, crowdsourced data can be helpful for. And even beyond operations, we're seeing a lot of new applications in transportation planning and traffic safety analyses as well. So the limits are kind of boundless there. A few updates on from the FHWA EDC 6 crowdsourcing team. Our next webinar is coming up next month, September 21st. The topic's going to be free navigation app data for better operations. So if you're interested in free data from navigation app companies, please register and join us for that webinar. On the training front, we have developed and is now ready to be delivered a course that can be, it's specifically intended for LTAP agencies and to be delivered to local agencies, but it's basically a course in a box that's got all the training materials that you would need to deliver the course, all the instructor notes. Everything is prepackaged and it's freely available through our team. So if you're interested, you can contact your local LTAP center, or you can contact myself or one of my co-leads, and we'll help you get more information about that course. It can be delivered between 1.5 to 4 hours virtually or in person. And then finally, another update, our monthly cohort meetings are continuing. If you haven't been part of these are informal, small groups. Honest discussions about the challenges and successes of using crowdsourced data. They take place the fourth Monday of each month at 2 p.m. Eastern. I know many of you have been on those calls. Hope you got some value out of them. If you haven't and you're interested, please contact me or one of my co-leads. We can get you invited to those. Next slide, please. Okay. So I think at this point, I'm going to introduce our first presenter. That's Kelly McVeigh. Kelly is a principal engineer at the New Jersey DOT. He's a supervising highway engineer. He manages the planning, design, construction, and operation of advanced arterial management systems at the NJDOT. So Kelly, we really appreciate you joining us today, and I'm going to go ahead and hand it over to you for our first presentation.
Thanks, James. Let me go ahead and share my presentation. Hold on 1 second. There we go. Are you able to hear me?
Yeah, sounds good.
All right, thanks. So as James said, my name's Kelly McVeigh. I'm the supervising highway engineer for a group within the New Jersey Department of Transportation called Arterial Mobility Management. And we're responsible for the planning, the design, the construction, and the operations of our advanced traffic signal systems, primarily adaptive traffic signal systems, with some more traditional controlled traffic signal systems. So today I'm just going to explain a little bit more about the arterial monitoring program here at NJDOT. I'm going to give some examples of how we use crowdsourced data for real-time monitoring, how we also use the crowdsourced data for performance measurement, And then I'm just going to have a slide where I talk about some of the next steps where I think we could be headed using data such as crowdsourced data. So a little bit about the arterial monitoring program here. It's something that's been in the works for a couple of years. Started with just a handful of us monitoring systems that had been constructed. And we realized that as we expanded our network of advanced traffic signal systems, we would also need to expand our capabilities for monitoring them. So we have an arterial management center at the Trent headquarters at NJDOT, where we have a video wall where we can monitor things like the image detectors. We can monitor the actual data coming out of traffic signal systems. You might recognize some of the graphics there on the right-hand side of that video wall are graphics coming from our SCATS adaptive traffic signal system. And we have a consultant who actually sits in that room from 7 a.m. to 5 p.m. currently, Monday through Friday. And they provide monthly reporting of signal performance, not in a very standardized format. What they'll do is they will generate essentially cases of, PowerPoints describing cases where either an issue was identified, how it was identified, how it was verified, and then what changes were made, and then what was the result. So kind of like a miniature before and after study for each one of the cases. And the crowdsourced data plays a big role. So as James had mentioned, it's definitely a more financially acceptable way of determining what's going on the roadway, as opposed to just completely inundating the roadways with instrumentation out in the field. And so we do have, some readers that radar detectors, and we do have image detectors that collect data for us. But we generally use the crowdsourced data. So just to give you an idea of from a network standpoint, what's the size of our network here? So in New Jersey, there's several corridors that have recently been constructed and are in full operation. We're constructing currently about I think that's about 70. I think it's 73 signals in construction, and then we've got 118 signals that are in final design. So we are expanding, as I mentioned before, our advanced traffic signal network. And it's just to give us some context here. Why are we doing this? Well, in New Jersey, traffic, fluctuates quite a bit. So having advanced traffic systems, especially adaptive traffic signal systems, plays a key role there. But even more importantly, there's some specific policies and procedures that we have to follow in the state of New Jersey when determining how to update a traffic signal timing, and what kind of data collection, what kind of effort has to go into actually updating timing parameters. And having an adaptive system makes that process much simpler. So we're able to respond to issues much faster. So on to some of the data that we use in terms of crowdsourcing data. There's two platforms that I'm going to go over. The first one that we use, user interface platforms that we use. The first one that we primarily use is something called the SPATTLE tool. I believe it stands for, if I can remember, selected priorities applied to evaluated links. And it's something that's developed by the Transcom Coalition for the New Jersey, New York, and Pennsylvania, the tri-state area. So we will use that in terms of real-time monitoring. There's, a map interface, much like if you were to log into Google Maps or any other mapping application, and you can see things, such as the current speeds. It also provides some good information like what is that speed historically, so we can get a good idea of, is this something that's normal? Is it something that we need to now look at our cameras, look at additional data, from the traffic signal system. Is our traffic signal suddenly trying to increase its cycle length out of the norm? And why? Oh, there's a lot of congestion here that is not historically there. So it's a useful tool. And it also is interesting because it provides some information on the data source, and I'll get to that in a slide. Here's just another example of the same type of data. It's a dashboard that we'll have. Generally, we'll have the dashboard on one of the computers in the Arterial Management Center, and we'll have our corridors. So this is an example of one of our corridors, Route 18, and specifically in the northbound direction. So we know if there's directional, if there's a priority direction that we want to focus on, we can very easily set that up. And setting up a dashboard like this, once the data is in the Transcom Spattle tool, setting up a dashboard takes, about a minute or so. You just have to select the links you want, maybe 5 minutes if you're looking for the links. And again, it provides a lot of good quantitative data here. What's the current travel time? Historically, what is it? Gives you delta. That's what you see in the incident delay column. That's the difference between calculated travel time and historical travel time. And then you can also see, is it close to free flow travel time? What's being measured, around midnight, 1 o'clock in the morning, 2 o'clock in the morning? And is that comparable to what we see here currently? So as I mentioned, there's several data sources. And so one of the unique things about the platforms that we use, especially the Transcom Spattle platform, is an agency that is subscribed to certain data sources or, has certain data sources. Transcom will set up an API to connect to the original data source feed. So for example, the TrafficCast Bluetooth data that comes from their travel time re-identification Bluetooth readers. And so Transcom will actually take that data in. We will inform them where it is, so what roadways, what mileposts, and then that will become an additional layer within their data fusion engine is what they call it. And really it's like a data layering engine, meaning they're able to, on one section of roadway, a user can see what is the Bluetooth travel time versus the here Navtech, previously Navtech travel time. INRIX, if they have census pucks in the ground, and then Traffic Now data, which is another vendor that provides a product called Deep Blue, which is re-identification Bluetooth reader data. And so there's several data sources that can be used, and a user can actually go and select those sources specifically to see where they are throughout the state. So you'll see little, if you look at the map of New Jersey, little speckles of Bluetooth TrafficCast data versus more, a fuller coverage of, INRIX or Navtech. Another platform that we also like to use, not as much from a real-time performance monitoring, but I just want to show that it's similar in sense that we do have the ability to create dashboards as well. And this is using the Probe Data Analytics Suite platform that is developed at the University of Maryland, the CAT Lab. And so here you can see, very similar to that dashboard I showed before, this is showing us very specific locations. In this case, I did both northbound and southbound. And for this dashboard, as opposed to what we do with the Transcom Spattle platform, using this platform, we have taken our INRIX data that we subscribe to, and that's what New Jersey is able to access through the Probe Data Analytics Suite. So now just moving on to some performance measurement. How do we do this? So pretty straightforward. I put a flow chart up here just so you get an idea. But vehicle probe data is great for identifying issues. When you're looking at it in real time, especially in a map application, especially when you have access to a layer that tells you what the historical data is, it's a very useful tool for someone to just look at a map, whether they're a traffic engineer, an operator, could be someone in administration just walks in and they go, man, something is going on there. It doesn't look right. It is very intuitive. So we identify issues. We also, if we get a complaint or something, we can use this data to verify that. We make changes to our system. So I mentioned we can respond very quickly. We can say, hey, this is going to require more bandwidth for our main line. We need to get a southbound progression pushed right away. We go in, we make changes. And then what we'll do is we'll look at how the vehicle probe data has changed. So we measure it. And one of the benefits here also is that these platforms keep this vehicle probe data historically. So it's easy to say, okay, we made a change. We know what time we made the change. Now let's go back and take a look at what it looked like before. And then we can go back and update the system again if we have to, if it seems like the change we made hasn't had as much of an impact. So a little bit more about the Probe Data Analytics Suite. We use this more, as I mentioned before, Spattle is a good operational tool. We also use that for performance measurement, just to pull some simple travel time graphs and things like that. The Probe Data Analytics Suite has several widgets, I believe is what they call them, widgets, but one of them is called a bottleneck ranking tool. And we really like this because you can, as the user, just say, hey, I want to see what the worst bottlenecks are. And you can do it by county, you can do it by multiple counties, you can do it by roadway, however you want to select it. And we'll go in and do this generally once a month or once every 2 months. And we'll see what are our worst bottlenecks, when are they occurring. And you can see here that for this, in this example, this is Route 73 southbound at Marlton Parkway. It's a key bottleneck intersection for anyone local to the Burlington County area of New Jersey. And you can see that it primarily is happening in the latter part of the day. It's not really an AM peak issue. So when we go back into our adaptive system, we can see what are the parameters that we're using, what's the parameters that the adaptive system is selecting based on these various times of day. And then we can start writing certain rules within the adaptive system to say, okay, during PM peak, we're going to go ahead and do XYZ when we measure, ABC. And we've actually had some success here, measuring volume leading up to the PM peak. We've made some adjustments at this intersection, and we had seen in a before and after about a 45% reduction in travel time from the Route 70 interchange down through Marlton Parkway, which was a pretty good improvement. And then just one quick case study to give you an idea, just a little bit more visual on how we use this data. This is a performance measurement example. So we had known that there's an issue on Route 1. This is Route 1 northbound approaching New Road in South Brunswick Township, which is in Middlesex County. So Route 1 is a principal arterial that runs parallel to the New Jersey Turnpike. And we knew during the PM peak in the northbound direction, there was some congestion that was building that we could see via cameras. There's a lot of cameras on Route 1. And also the probe data was helpful in verifying that. And so what did we do? We used the Spattle. These are snapshots from the Spattle tool where we can select the links. So when we're very specific in the links that we need to select, the Spattle tool is good because it's a little bit more granular than the Probe Data Analytics platform. And what we did was we picked the northbound link, and knowing that we were going to make a change to Route 1 main line that could have a negative impact to the side street route, we also selected the westbound approach link on the side street, knowing that was the primary direction on the side street there in terms of traffic volume. And so we made a change, and then we were able to go back and do a before and after study. And I like to show this because sometimes you make the change and you think, yeah, it looks better. It looked like, a couple of times that we saw it through cameras with our own eyes. We're like, okay, it's better. But then you go back and you see this data and you're like, okay, well, at least on this day, this Wednesday, June 8th versus Wednesday, May 25th, there really was no improvement, at least not that we could see using this data. Then we looked at the travel time for Thursday. So it was Wednesday, then Thursday. And we did see that on Thursday, there seemed to be a bit more of an improvement. And we had kept our eye on this for a couple more days and saw that it generally had improved the main line travel time northbound approaching that intersection on that link. And so that was good. And so we wanted to see what happened to New Road. And, you know, you can see that there's essentially around that same time, there really is not much of a difference on New Road. I mean, a 3% difference when your travel times a little under 1.5 minutes is not too much for that link, especially when it was it's that entire link approaching Route 1. And then we did see a little bit of an increase in the travel time when looking at Thursday. So that improvement that we saw on Thursday on Route 1 northbound, you can also see a slight degradation here for the side street approach on Thursday as well. And then the last slide I have here is just some of our next steps. We're really starting to focus on how to automate a lot of this. So currently we have so much data. These platforms automate the data in terms of being able to look at it when we want to in a user interface, but finding ways to then be able to spit out produce a report that we can then show. I currently have, if I had to guess over the last year, I might have about 25 to 30 PowerPoints that explain these various cases where we made some changes here and there and we saw these improvements. Quantifying that at a high level for management is an important next step. And so we started looking at the ATSPM platform. I really like what I've seen Georgia DOT do with Kimley Horn in terms of the SIGOPS metrics. Used to be called the Mark, I think it was called Mark IV platform, but now called SIGOPS. And then what you'll get to see in a few presentations, Allyson in the I think it's the Austin area. The platform that they have in terms of their reporting capabilities is something that New Jersey is very interested in. And so we hope to find more information on how to make that happen. And with that, thank you.
Great, thank you, Kelly. Great presentation, packed a lot of information in there and covered a lot about how you're using crowdsourced data, both in real time and in an archive measurement manner. So thank you. I see a couple questions. Kelly, you'll be able to stay on at the end and we'll do our Q&A and can address a couple of these questions that we have for you. So thanks, Greg and Mohan for putting questions in the chat pod. If anyone else has questions, feel free to go ahead and put them in there. Best place to do that, so we have a record of it and make sure we don't forget it, and we'll address them all that we can at the end. So thanks again, Kelly, and we'll bring you back at the Q&A session. At this point, I'm going to introduce our next presenters. Ashley Moran is a transportation planner with the Acadiana Planning Commission's MPO, Metropolitan Planning Organization. She has a certification from the American Institute of Certified Planners, and she works in data analytics, project development, and public involvement. And with her, a tag team is Hunter Fontenot. He's an electrical engineer for the Lafayette Consolidated Government and the Traffic, Roads, and Bridges Department. Hunter graduated from the University of Louisiana at Lafayette and works with a mixture of traffic engineering, electronics, and web development folks. So it looks like a very interesting job you've got, Hunter. So I'm going to go ahead and turn it over to Ashley and Hunter. Go ahead.
Okay, great. Thanks for having us on. So we're going to discuss how Lafayette's Storm Road program, developed by Lafayette Consolidated Government, which is the main governing body for Lafayette City Parish, which is the county equivalent for most of the United States, and how we're working with the Acadiana MPO to take the data from their emergency response system to use it for our arterial roadway network to program projects and make improvements on our roadways to ensure resiliency during major weather events. So just to give some background on our community and our part of the world, Lafayette is considered by many metrics to be, you know, the 4th or 5th rainiest community in the United States. On an annual basis, we do get about 62 inches of rain, which is about double the national average for rainfall in the United States. Our high water mark was in August of 2016 when we received over 20 inches of rain in a 24-hour period, and obviously experienced many issues with that and with basically the complete shutdown of our roadway network system.
So as Ashley mentioned, we have a lot of issues with rain and flooding. We actually had a pretty good response to it. We had dozens of workers, trucks, chainsaws, ready to go for hurricanes and flood events. But where we hit the problem was we had no real way to manage them. A lot of this was being done by dispatchers who got a call and would use pen and paper to track these different requests, maybe even sometimes sticky notes and such. So we never really knew where our workers were, you know, which requests were taken care of, which ones are being duplicated. And we had a Hurricane Delta came through and we had thousands of requests. So trying to think about managing those without a system like we developed is just a nightmare. We also had no long-term data for storm events, and when our workers went out there, we didn't keep track of where we had been. So that was kind of the issue and why we developed what we did.
So as part of our long-term planning process for the Metropolitan Planning Organization and in developing our public participation plan, we did a lot of research on new communication methods, because when I started in 2005, you know, we did everything, you know, what we consider old school now, you know, just traditional public hearings, traditional paper surveys, paper comments, that sort of thing. And working with that, we really found there's been this huge shift societally towards digital interaction. Most people nowadays, like, you know, a lot of people say even text me or email me before you call me. And higher generations, this is a trend that is even more pronounced. And so we surveyed, through the development of our plan, we surveyed our government entities and we asked them, how are you collecting data on roadway flooding? And Lafayette was the only system that had kind of, within the past year, had developed a digital reporting system, but we still were missing those other communication methods. And we still were seeing the limitations of only dealing with phone reporting. But our other jurisdictions are only still using phone reporting and paper documentation. So they really had no data to provide to us with regards to flooded roadways. So during, while in the midst of we were working on these issues, we had Hurricane Ida happen, and Hurricane Ida affected the parish where my family lives, and Hunter's family has a lot of family that live in that parish, St. Charles Parish, St. John Parish. And there, we noticed while we're monitoring it, there was huge amounts of people interacting and reporting things via social media. And I was monitoring it because my dad and my brother had stayed in St. Charles Parish, and they had had a tree fall in their neighbor's house. And they were, you know, trying to plan to see how they could get out. And people were actually posting on Twitter, on Facebook, where roads were flooded at. So I knew which roads were flooding and which intersections were flooding, so I could help them in case they needed to leave if they had some sort of major event like that. And so through the research, we were working with communication tools. We really found a lot of good data to support Twitter as probably the best social media or the easiest social media to integrate, because it is used for a lot of breaking news. It's more news focused. It's very similar to the communication tools when you're working with a cell phone. So, and a lot of the research from the Pew Research Center supports that. So we were excited to see that, and we were excited to integrate it into the disaster reporting system. And so, you know, as kind of more trends that we were seeing, this is the sheriff for St. Charles Parish. You know, he's asking people to not report things via social media. And I think it's just because these younger generation is just so used to this form of communication. And we're really missing it. We're really trying to work with our local governments to see how we can capture this information and integrate this, because this is the way the world is going. We need to figure out how to get away, or at least integrate our older school methods with our newer school methods.
So what we developed was an online platform that essentially is a Google map where our dispatchers could put requests. Those requests then went to our workers in the field. So we gave iPads out to our workers in the field, one for each crew, and they were able to look at this map, which we'll show in a little while, and actually tell us, okay, we're here, we're working, we've completed this one. And so we could more easily keep track of the requests as they come in, where they're at exactly. And we didn't want to duplicate requests as well. So we also we recently put in a Twitter component so that people could reach out on Twitter. They could tag, right now it's hashtag storm mode Lafayette, and it'll show up to our dispatchers. So they could put these requests into the system from there. And everything in this is archived. We're keeping it for historical purposes. We want to use that data to plan out our roadway resiliency. Here's just a screen that kind of shows a screenshot of the actual program. On the left, you see the mobile view. And each little, it's kind of hard to see, but each little blockage or tree or any icon you can see on that map represents a different type of request, of issue that's been reported to us. And if they change color, that's them saying, if it's yellow, they're working. If it's green, it's been completed. On the right side, you'll see a desktop view. This is where our dispatchers will sit on this screen, and they can put in a new request while at the same time looking at the requests that already exist in order to make sure we're not duplicating stuff. This is just a technical page. Most of you probably look at this page and see gibberish, but a programmer will look at this page and say this is pretty basic. A lamp stack is, we provisioned an Amazon web server and then put a LAMP stack on it. And LAMP is an acronym that stands for Linux, Apache, MySQL database, PHP. And what this is basically Linux is an operating system. It's like Windows, but different. And then Apache is a web server, which helps us actually host the website. MySQL is a database that stores all the data, and PHP is the coding language we used. This is a pretty typical stack that's been used for a long time now. It's actually a fairly basic program. And this is an up-close shot of the My Jobs tab we have. This is where a worker could come, look at all the different things he's been assigned, and you could see that this particular issue we clicked on is trees and limbs. It's assigned to Hunter Fontenot. Its status is completed. So we have a few more details in here. We can update the status of it, whether it's working or not. And this page actually is customized based on the person who logged in. So I can see a lot of them because I'm in a management position, but a worker out in the field will just see what they've been assigned. This next page is the new request tab. It's a tab that our dispatchers sit on. And when a request comes in, we log a certain amount of information just to be able to get out there and talk to whoever requested it. And we can also zoom in and see like if a request has already been made at this location. We don't want to duplicate it. So yeah. And this is the Twitter. This is a small page on the Twitter API. So the Twitter component, Twitter actually puts out an API that you can grab data. You can search by hashtags. And then I put a little link there to the component we use to connect that with PHP. So this is how we're using Twitter inside this program. So this is a screenshot of the actual Twitter request page. If you'll look on the left, kind of the bottom left corner, you'll see the Twitter request tab has been selected. It's highlighted blue because there's a new tweet. The tweet in the middle has a highlight of blue around it as well to show that it's new. As you can see, each of these tweets has either storm mode testing or storm mode Lafayette in a hashtag. And we gave 3 basic options, which we'll go over in a video in a second. But the 3 major options are to make a request, to put it in as a legitimate request, to acknowledge the tweet, to say it'll actually send a tweet back to the original tweet saying, a very generic, thank you for submitting a request. You know, we appreciate it. And then the last option is to hide tweet. If there's any extraneous, malicious tweets or anything like that, we want to be able to hide them so that we can really get to the meat of any of the problems. So now we have a video, I believe.
Yeah,
there we go. So it's showing that, you know, any hashtag storm mode testing or hashtag storm mode Lafayette will show up in this system. And I believe they go through the buttons actually backwards in this video. So we'll start with the hide tweet is being shown. So a tweet comes in at the bottom there. And let's say this one's extraneous, we hide it, it disappears. This next one, we acknowledge it, it'll send something back to them. And then they show, they'll make a request, will pop up with a similar thing to that new request tab to put in the same information. And it actually grabs information from that tweet and puts it into that request automatically. So some other social media considerations we had, naturally, Facebook was a big one because it's the biggest social media platform. However, in 2016, they actually shut down their API. Now that may just be to general users. We're hoping to reach out to them as a government entity and talk to them and say, hey, you know, this is for safety purposes. Could we please access this? Because it does exist, it's just not available. And then Waze was another platform that naturally fit with this. Since we have data to share with them, they would share data with us. It's kind of how they work. And so we are actively pursuing ways to just better this program all the way around.
So from the planning side of it, the really exciting aspect of this is having all this information on flooded roadway requests and for our resiliency of our transportation network. So it's really helpful, and you can see, and this is what we get the archive, what it looks like. All the points represent a request that was managed and deemed verified by Lafayette Consolidated Government. It gives the name and date of the event, which obviously is helpful for meteorological purposes because we know, how much rain fell on a certain day. And it even provides the timestamp of when the request was submitted. So we have that as well, because then we know by time how much rain had fallen by that point. It provides the address, again, a pivotal information for analyzing street flooding issues. And it provides, in this case, this is a street flooding related report. But they also, like you mentioned, trees down, things like that's really important. Trees falling down is obviously a very dangerous situation on our roadway network. It definitely can impede operations of our arterial network system. So we're really, this is the data that we get, and it's really exciting for us to analyze. And this is just an example of a heat map of the data requests was it related to street flooding. But it's very important for us in Louisiana to have this data because we do get a lot of requests through our programs for raising roads, based on flooding issues. And we really need to have that data for that because a lot of people will say, hey, we feel like this road needs to be raised, X amount of feet. And we need to have the data to support that because this is all very data driven. A lot of times we don't really have anything other than more anecdotal data for doing this programming. But again, it's important for us because in Louisiana, because we do have issues with regards to flooded roadways impeding emergency response for crashes or even things like heart attacks and such where, a minute makes a big difference. And then we do have, unfortunately, some motor vehicle crashes related to inundation of the roadway where people have drowned in their motor vehicle. So we need to make sure that we're not getting that level of street inundation on our major arterials. Again, application purposes, the PROTECT program, obviously big program for metropolitan planning organizations and state DOTs that is directly related to roadway resiliency. And we programmatic as well as competitive. And we will be using obviously this data for analyzing and developing projects. Integration to our preservation projects. So the picture you see right there, that is of a roadway project that's through our, what we call our pavement preservation program with the Metropolitan Planning Organization. For our overlay program, we do frequently do drainage improvements integrated into our pavement preservation projects to ensure the resiliency of the roadway. In this particular case, unfortunately, this roadway was already under construction when they discovered this issue with this particular head wall that needed to be replaced because it's about to collapse, possibly, during a high weather event, which obviously would be a major issue for this particular community because it is a major arterial for them. So this data is really pivotal for us to be able to make these improvements on the front end of projects. Because right now we're working with a lot of anecdotal data and then just going out, unfortunately, just going out in the roadway when we're having a heavy rain event to see before we start the preservation process on the roadway. And then long-term planning, resiliency in Louisiana is a major planning factor for us. We need it for, obviously the reasons mentioned, but it is a big part of when we're doing our long-term project selection and integration, we need to have this data. So this is our contact information. And I know we're taking Q&A at the end, but thank y'all for letting us have on and talk about our projects, and we'll be happy to take any questions or any contacts that somebody would like to make.
Great, thanks, Ashley. Hunter, excellent presentation, very interesting. And I know a lot of agencies have struggled with how to harness the power of social media, such a powerful way of collecting data. So you've definitely proven you can do that. And I like how you've addressed a specific problem. And that's kind of the rule number one with using crowdsourced data. Don't just do it because it looks cool or other people are doing it, but make sure you're addressing a specific need or problem that you have. And you've definitely done that with your flooded and closed roads during storms. So again, thank you. And we'll bring you back for the Q&A. Reminder, just put any questions you have for Ashley or Hunter in the chat or Q&A pod, and we'll address those at the end. So at this point, I would like to introduce our final presentation speakers. Allison Ritchie is a transportation analyst at Kimley Horn, specializing in traffic signal operations, illumination design, and traffic projections. She currently serves as the manager of the Austin Mobility Management Center, which operates approximately 1,000 signals within the city of Austin. Allison's a graduate of University of Arkansas, and prior to her time in Austin, she worked on numerous highway and residential illumination designs and traffic projection projects in Texas. With Allison today is also Sean Quayle. Sean's a senior traffic signals and safety engineer with INRIX. Sean's a professional engineer with over 20 years of experience in consulting, public sector, traffic engineering, and now in the private sector. So thanks, Allison and Sean. Sean, apologize for not having your picture on there. Our public affairs office wouldn't let us because you're with the vendor. So, but you're certainly welcome to help and present with Allison today. So at this point, I'm going to turn it over to Allison. Take it over.
Hey, good afternoon, y'all. Let me get my screen situated over here. Thank you guys for the presentation. Excited to be following up such a wonderful group of panelists. I'm here today to talk about how we at the City of Austin are using crowdsourced data sources to help influence and improve our traffic management center operations. And at the very end, we'll get some information from my partner, Sean, who's a representative of one of our data vendors for how they're gathering and collecting that data for us. So to give you an idea of how we're using our system and how we're influencing with all of these different data sources, I thought it would be a great idea to step backwards and talk about what our system is as a whole. So we are a mobility management center. I know the industry term is often TMC. MMC we felt was more representative of all the different forms of transportation that we support and design for. In our current formation, we were expanded in 2016 with Kimley Horn as our prime consultant, and we are an active management center, meaning we are using real-time data to influence and respond to activity in our traffic system. So this includes about 200 miles of critical arterials with about 250 miles worth of fiber optic cable, so we can have that near 100% communication uptime with a multitude of our devices. We also use close to 200 cell modems to get to our peripheral areas of our system. But this is a real-time signal adjustment such that if you are unfortunately involved in a vehicular accident in our system, we can use our assets to be able to understand the complexity, severity of your crash and be able to respond to that with a signal adjustment, perhaps reaching out to our PIO office or other sort of social media avenues to be able to get information out to our travelers as quickly as possible. We also dispatch technicians based on feedback we're receiving from our system. We use an advanced traffic management system called KITS that gives us real-time information as far as the status of not only our signals, but other peripheral devices like our battery backup system and CCTVs, such that we're able to send technicians out and get those systems repaired if we're unfortunately not able to repair for them from a remote setting in our MMC. We're also involved in the event space, which I'll talk about here in the second half of our presentation. The city of Austin has the luxury of having a lot of different avenues to host a myriad of different events, all the way from CODA, hosting F1, which boasts, I think, nearly 450,000 people over the course of 3 days, all the way down to Austin FC. We're very excited to have our first professional soccer team here in the city. Lastly, we also are involved in emergency response. So large rainfall events, wind events, both for our municipality and for surrounding municipalities, we're able to gather our forces and get folks out into the field to get that infrastructure back up as quickly as we can. Just by the numbers, if we were going to break down our system and see how that would look, here's some quick baseball card style facts for y'all. We manage close to 1,100 active signals. If you bring in signals in design, it's closer to 1,400, which is pretty exciting. We're managing also nearly 650 traffic cameras. These are a host of different models that we're using. So we're able to log these in both at the intersection level as well as some high-rise cameras, which are really helpful to see progression across multiple signals. We also manage some dynamic message signs. So the buckle up messaging that you often see on freeways, we also have some inside of our city system. We also, in conjunction with that, manage school zone beacons. With the beginning of school for a lot of us, I know that this is at the forefront of our mind, and we're pretty excited to be able to host those not only for Austin ISD, but surrounding municipalities as well. One of the big data feeds that we use is a 311 call center with the city. So if a community member has a complaint either about a signal operation or would like to report some form of damage, they would call 311 and that ticket will get routed to us in the form of a citizen service request. And we manage to close to nearly 1,000 of those a month. You can see our hours of operation here. We are not a 24-hour facility. We have a technician available 24 hours a day for emergencies. If, you know, for example, a PED pole is knocked down or a signal's in flash, we don't necessarily want folks waiting till 8 or 6 o'clock in the morning for us to be in office to get that repaired, in which case we can send that out overnight. But for the engineers on staff and other folks, those are our hours of operation. I've listed our staffing over here to the right as well. There are 3 managers, kind of a morning, afternoon, and evening manager, 2 operators to help us dispatch technicians as well as process those citizen service requests, and 1 data analyst to help us really dig into a lot of this good information provided by INRIX and other vendors so that we're able to evaluate and improve our signal operations. Lastly, I talked about moving out into the field and getting our hardware repaired if needed. We manage about 20 field technicians. That includes technicians both able to respond to what we consider trouble calls, which are emergency repairs and things related to that, as well as planned work. So if that's a flashing yellow arrow upgrade or something associated with that, we can use those techs as well. So talking about data feeds and how we're able to bring all of this information together, sometimes it does often feel like we're drinking out of a fire hose. You know, there's information every corner that you look at, but we really want to have an understanding of how we can succinctly process this data to have a better understanding of how to improve our system. So doing so, we utilize numerous disparate data feeds. Some examples here are shown on the screen. You'll see that top right picture is our ATSM software kits. So that's giving us information about our signals real time. Often, I know that picture is part of grainy, so I do apologize. We're able to see what signals are online, what signals we don't have communication to, and other important statuses such as conflict or police flash. That's picture at the very bottom where it says data tracker. That is our 311 system so that we're able to integrate that with our asset management system built in-house. So we can not only track dispatches and get that back to 311 so they can get back to the appropriate community member, but we can also track inventory and other important metrics so that we have an understanding of where we stand with our hardware. The middle 2 photos are examples of both a public and private data feed. We're active on Twitter like many folks are. So at Austin Mobility is where we post information related to crashes to inform the public to perhaps find a different route before they leave their house, as well as major closures, special events, and things related to that. I often like to say if the marketing team is tweeting from this account, there's emojis and it's very cute. And if the engineers are, there are no emojis. So that's how you're able to tell what's in-house and what's not. Lastly, an internal data feed that we use is a CAD dispatch system related to our fire department. So we're able to see where they are being dispatched for emergency response. And although not information and events of that nature are always of interest to us. For example, an elevator rescue might not be exactly pertinent to your transportation network. It is helpful to see instances such as a traffic injury or a vehicle rescue so that we could know major responses and be able to adjust that accordingly. I mentioned earlier that the city has the luxury of having a lot of different special events. And just to name a few, like we've talked about, F1, Austin FC, UT football, and the like. We've extended hours, meaning beyond that standard staffing window that I shared earlier, to about 75 events a year. So if you've ever attended ACL or South by Southwest, which we'll talk about here shortly, we extend our hours to be able to facilitate ingress and egress appropriately and be able to manage those systems in real time. And we've had the luxury of working with our partners at INRIX to be able to not only prepare for those events and plan our signal adjustments, but as well as evaluate their efficacy from perhaps a weekend 1 to a weekend 2 and better improve our experience for ridership and the city. So moving specifically into the special events I'm talking about, I want to take a moment to reflect on a special event that we just had earlier this year, South by Southwest. So if you're not familiar with South by Southwest, it's an annual tech conference that lasts 10 days, usually in mid-March, all over the city of Austin. It started in the early 80s and has just been ballooning ever since. It's quite an interesting event and a kind of different beast than working something like a UT football or ACL, in which case it is very standardized, when folks are coming in and when folks are leaving. And that South by is kind of known for having a lot of pop-up activity. So, you might have a pop-up Harry Styles in a small bar district that you didn't expect to. And so suddenly, you're having a large influx of folks moving to an area that you perhaps didn't necessarily plan for or is non-standard compared to a regular travel pattern. So we like to use this event as a great example and opportunity for us to not only kind of flex our muscles as far as how efficient we can make our traffic system, but how readily we can use our data sources to be able to improve our experience from week to week. What you're able to see here is, like I mentioned, there's a couple of photos of both the tech side of the conference, which is normally in the front half of the week, to the more music-centric side of the conference, which is normally the second half of the week. But these are just some examples of what we call central commands. So we're telling a signal to run something different from its standardized time of day pattern, and we can command that not only to an intersection or perhaps a corridor, but we can do that to any part or subset of the town. So we can command all of the downtown core, for example, or all along Cesar Chavez, which is an east-west route in downtown, or things related to that. So using signal analytics, using our INRIX data, which is trajectory-based data provided by INRIX, which has a proliferation rate of anywhere, I think, from 5 to 10%. Sean will speak on it later in our presentation. We were able to decide how we're going to adjust our signal plans from weekend 1, which was the first part of South by Southwest, to weekend 2, which is the more music-centric side. So I've included some examples of how we were able to take data from weekend 1, make a signal adjustment, and apply it to weekend 2. So what we're looking at here is a cutout from signal analytics, and we're looking at IH 35 and 11. So right downtown, major inbound traffic and outbound traffic for folks coming into the event. And you'll notice that that northbound left on weekend 1 was around 1.9 minutes. So you'll see a level of service associated with every movement. And dark red is generally not something we like to see. It's a lot of delay. A lot of folks are turning into downtown to attend the event. So it was not terribly surprising that we were seeing a lot of delay in this movement. The red is indicative that it is not necessarily standard for the historical data that we're seeing. Generally, we're not seeing that many folks trying to turn left into downtown for the PM peak. So we knew this was event related. So between weekend 1, we made an adjustment and gave more time to that northbound left as it had from weekend 1. So weekend 2, when we were able to take that data point, we were able to save around 54 seconds in control delay for folks making that movement. Similarly, in a different part of town, we saw something very similar where a southbound left at 7th and Comal. So we're still downtown. We're still positive that this is event traffic. They were experiencing a delay of around 1.1 minutes. And after our adjustment, comparing weekend 1 to weekend 2, we're able to save folks 34 seconds. Now, I want to take a moment and understand that not all of our data is in a black box, right? Data does not tell everything. Just because you made an improvement somewhere that you think, oh, well, this is, signal operations 100%, we're going to be able to see that benefit pretty quickly. There is sometimes a little bit of a drawback. So 7th and 35. So this is also in that downtown core, folks going into the event, or in this case, moving from the west side of downtown to the east side of downtown. We made a signal adjustment that we thought would really help those folks out. And it turns out that it didn't exactly one-for-one benefit like we saw in our other areas. And this could be for a myriad of different reasons. In this particular instance, I believe there was a car crash or something in this area, and they had multiple lanes blocked on this intersection. So, even though we made the adjustment in our minds that we expected to see some level of improvement, it's a nice reminder that you need to take into multiple different data feeds from multiple different sources to be able to have a true understanding of how you can better operate and maintain your traffic system. So we're all reporting to folks, and we all want to make sure that we can communicate our benefit not only to other engineers that perhaps have a clear understanding of how our traffic, ATSPM, and performance measures are calculated, but as well as to folks that might not necessarily be engineers and need to understand that. So this is a dashboard that we've built internally using Power BI. We're taking an internal spreadsheet that we kind of record all of our MMC actions, is what we call them, and we'll be able to calculate that into user savings. So we're taking an assumed delay, an assumed vehicular volume, multiplying that by road user costs, and it results in savings for the traveling public. So we're pretty excited that we're nearing $500,000 in benefit this year from not only responding to signal timing adjustments, using that fire data, social media feeds, and other crowdsourced data sources, but also being alerted to infrastructure repairs, perhaps a stuck detector or a stuck push button, as well as incident response like those crashes I was talking about. So very excited to talk about it, but all of this would not be possible without our partners at NRIX. And this is where I'll hand it over to Sean.
Thanks, Allison. That was great. And hopefully you don't mind just passing through the slides here. Covered a lot of ground there. Crowdsourcing has been a great discussion point so far. Allison, can you maybe go back one slide there? So as Allison was talking about, that previous dashboard was great. They're taking the delay metrics that are pulled from NRIX signal analytics data to allow folks to be able to see movement by movement what's happening, as well as overall intersection delay, and providing that user cost from time savings. So the signal analytics package really is a web-based crowdsourced tool. There's a dashboard, there's intersection level data, there's corridor level data, and then there's some custom reporting that comes from our partner, the CAT Lab at Riddis, University of Maryland. Let's go to the next slide. And so our data is coming completely crowdsourced. It's probe data. It's vehicle to X, vehicle to the cloud. We're only using high frequency data. So there's a lot of different data sources for probe vehicle out there. We're taking only the highest frequency. So the data has to report in sub 5-second intervals for us to use it. We're making that determination because we want high fidelity information with which to understand stops, delay, travel time, some of the things that I'll talk about, but no infrastructure is required for this crowdsourced data. It's just flowing from a map, and I'll show you what that looks like in a second. Let's go to the next slide. Thanks, Allison. So you've all seen a time-space diagram. That's effectively what we're showing here. And as you click through the slides, what we basically do is put a box around every intersection across the entire country. So we have information at all of the signalized intersections that are in our map provider, which is the vast majority of the United States. This allows us to do fair comparisons between the intersections across the city of Austin or across county, city, states, but allows us to look at free flow travel time. So somebody that travels through the intersection without stopping. And then we can also look at those locations where people are slowing down, stopping. Those are arrivals on red, because we assume people are acting rationally. And then we can also look at the speed on approach. And if somebody's stopping more than once before they make it through the intersection, we're labeling that as a split failure. So we're getting some pretty interesting metrics that are equivalent across intersections like at the city of Austin with this crowdsourced data. Let's go to the next slide. So some of the performance metrics that we pull out for the city of Austin and others, travel time, turn ratios, again, it's probe data, so it's not a count. It is a subset of the population, and Allison's right, it depends on where you're at in the country as to what that capture rate is. I will say that we did a national report card that looked at last fall to last spring, and we saw a 13% increase in our sample sizes. So the trajectory is definitely up with crowdsourced data for signal performance measures. We feel really confident about the ability to reflect larger movements for a single day. And then for our movements that maybe don't have quite as much volume, we can start stacking the data and looking at it over multiple days, multiple weeks, or even multiple months. So let's go to the next slide, Allison. When we built this tool, we got input from agencies. This is actually a survey that was done related to professionals all across the country. What signal performance measures were people looking for and how were they going to use that data? And then we used this to help drive the product so that we built something that focused on those most highly, at least stated, things that people wanted, you know, percent arrival on green shown in the top right there. Travel time and travel time reliability right below it. And then to the left of that, we're looking at split failures. And then at the very bottom here, we've got vehicle delay, which is the case study that Allison showed. All of this information is directly pulled from the vehicles, crowdsourced. And then we can use that data to infer when delay changes, when percent arrival on green changes, that something has changed in the network. That might be something that we know as an agency has happened. It's construction or a special event. We still may want to make adjustments to our timings based on that. But more often than not, as a user of this tool, when I was at the county, I would use those changes in delay as inferences that something's gone wrong. I would say that a good portion of the complaints that we got ended up being root caused in detector failures or communication failures or other signal infrastructure failures. So this is a way to use crowdsourced signal performance data to help us understand our network better and proactively find those problems quickly. Go to the next slide, Allison. So these are just a list of kind of the use cases for this crowdsourced type signal performance measures data, retiming, impacts, TSMO strategies, kind of prioritizing things. I talked a little bit about equipment failure, so I'm going to stop there. Next slide is our contact information, and I will look forward to the questions and discussion from the panel and the rest of the folks in the audience. Thanks for the time today, guys.
Great, thanks, Sean and Allison. Great presentation and great example of a public-private partnership and how you're able to use the data provided by INRIX directly in the MMC. I keep wanting to say TMC, but MMC there at the City of Austin. So we'll get back to Austin here with the Q&A, but first let's, if we can, pull up a poll question. So now that you've heard from our three presenters, I want to just take a moment and ask the audience whether your agency or maybe your client uses crowdsourced data for their arterial operations. So this poll question will be kind of a three-part question. Can we go ahead and pull up that poll question? Thank you, and give you a minute to answer that. We have on our EDC6 crowdsourcing website, a list of crowdsourcing application and case studies, and user cases. So we're always looking to update that because the field and the technology and state of practice is always changing. So be very helpful if you can take a moment, fill this out. Okay. So let's go ahead and thanks, Luana. Make sure you answer all 3 questions in this poll. Follow up if you've got a new case study or application that we have not come across before. Okay, maybe we can go ahead and close that one out. Thanks, Luana. So we're going to transition now to the Q&A segment. So I'm hoping Kelly and Ashley and Hunter and Allison and Sean are still on with us. A number of questions came in, and I'll try my best to answer, to get to all of them. One was a more generic or general question that I can address, and that was I talked about the crowdsourcing course that is available to LTAP centers. How do we get access to that? Maybe didn't explain that all that well. So each LTAP center has access to that course through their internal SharePoint site that they have set up. So you would need to contact your local LTAP center in your state, and they can get that through their Basecamp system that they have set up. If another option, if you don't know your LTAP center, you can go ahead and contact me directly, or one of the other contacts I present at the end, and we can also get you set up with the course materials and answer any questions you have about that. So good question. And so let's go to Kelly. A couple questions that came in for you. So first one, Kelly, was you mentioned your subscription to INREX, and then you had a slide that showed other logos of private sector data providers. Do you also subscribe to those? And maybe you can give a little bit more information about that.
Yeah, so some of the other data sources, when we purchase their product, part of the purchase of the product is also to subscribe to the data source. So for example, with TrafficCast, if we purchase the product to deploy, let's say, 10 Bluetooth readers on a particular roadway, then they also offer their data source platform. And as part of that, we let them know, we say, hey, okay, we also want you to allow Transcom to connect via an API so that we can go to your data and, at their website. Most of the time it's like cloud hosted, a web-based application. And then we also want it to be available in the Spaddle tool. So I showed census pucks. NJDOT, I don't believe we have any census pucks. I know the New Jersey Turnpike does. So the Turnpike Authority, the New Jersey Turnpike Authority, who owns and maintains the New Jersey Turnpike and the Garden State Parkway, they have census pucks on those roadways. And so I had included that as one of the data sources as well.
Okay. Great. Thanks, Kelly. I hope that answered the question for Greg. If not, please provide a follow-up there. And so it is kind of a confusing world, right, with subscriptions and different kind of procurement methods and data agreements and that kind of thing. So that can get complicated pretty quickly. One more that came in for you, Kelly. Maybe you can talk a little bit, maybe recap the metrics you use to find out if your strategy is effective. And seems like it's kind of a combination of visual inspection and some quantitative metrics. And then how do you do that? Is it mostly offline after the fact, or can you do some of that in real time?
Yeah, so the real-time measuring is really just, most of it's visual based. We do have those charts that give you some quantitative data, but again, there's no like additional analysis that's generally being done on the fly. It's more or less, hey, we see this issue here, we make a change, and then we're just visually, we are seeing how things are starting to be impacted by that change. The more of like the, quantitative part of things where I can say, hey, we improved, the travel time by 40% or 30%, that happens after the fact. So that's more like an offline analysis where we pick several days before a change was made, and then we pick several days after. Some of these platforms give you the option to do like averages over months. And sometimes you can do like too much of an average where it's like so watered down, where it's hard to really say, okay, the change we made was really significant. So we generally focus on maybe 2 weeks before, 2 weeks after, a couple of days here, a couple of days there. And then we like to do that comparison. I saw in the part of the comment was, let me see, or a certain percent increase in speed, or you could say similarly, certain percent in decrease in travel time. We don't really have at least here, we haven't really found like a particular bar that we try to hit. Like, oh, we want to see a 20% decrease in travel time, or we want to see a 10% increase in speed. We generally will make the change and just see directionally where it's going. And if we make more of the change and we can see a little bit more of a benefit, it's almost like we're estimating just how much benefit can we get out of making a change, like, changing offsets, for one direction. And then we're looking at the other, like I'd shown in my, in the one little case study. In that case, we were comparing the side street travel time. So you saw that the side street travel time really didn't change that much, and it went up a little bit. So we were like, okay, we got a little bit of an improvement on mainline. We haven't negatively impacted the side street too much. And so let's keep it there for now and see, we can always go back to it. So I hope that helps answer that question.
Yeah, great. I think you definitely did. So thank you. Thank you, Kelly. The next question that came in was actually for Allison. So Allison, can you maybe talk a little bit more about your 311 system? You talked about how it's integrated in with the MMC. And is it just feeding traffic related items, and how is it actually part of or integrated in with the MMC? Maybe you can give a little bit more information about that.
Yeah, absolutely. Thank you for the question. 311 is a call center hosted by the city of Austin, where community members have the opportunity to call in any sort of complaint that they have, be it traffic related or not. So if you have trash in the street or a traffic signal sign hanging down, maybe someone parking illegally, you can call 311 and the call center itself will disseminate that ticket, that customer service request to the appropriate parties. So although it is ingested by the MMC within our own data asset management system, it is not operated exclusively by the MMC. And if we took the system as a whole, it would encapsulate a number of other departments within the city.
It's a great example of integrated in different types of crowdsourced data, not only pro data, but also 311 data. It's crowdsourced directly from the users of the system. And so getting that in real time is critical.
Yeah.
The other question that came in for you, Allison, and maybe Sean can help, but it's kind of a three-part question. It's basically about how do you take social media data and integrate it in. So do you have information on what you perform for each social media data feed you have, and how do you use it? Is there an agreement needed? Is there a translation of the data when you ingest it? And then what else is needed to incorporate the data into your traffic management system? You could talk a little bit about that.
Right. So primarily through social media, we're monitoring Twitter exclusively. Sometimes when we see the occasional Reddit post, we'll look into that as well. But whether it be on Twitter or Reddit or any other associated social media feed. We do request folks to go to 311 and report there. We don't generally, as a standard practice and a best practice, work off of, you tweeting at City of Austin, fix this left turn. That's not a great way for us to be able to track progress. And maybe, eventually if it's a detector repair or something associated like that, it's really hard for us to be able to track that just off a tweet on Twitter. So we'll generally point people to go to 311 and then report it there. So as far as using that data, we're monitoring that traffic tag. We also use hashtag ATX traffic that we're able to search not only tweets that we put out, but tweets that our partners put out. We work commonly with Travis County, the paramedics and folks like that, and they use that hashtag as well. So we're able to just kind of search with that. So that's helpful for us to find information. But as far as us performing a service and operating to be able to check out inventory, make a repair, or any of that, we'll point people to 311. 311 can generate the ticket and send it to us, or we can generate the ticket in-house. We're able to go both ways. That system is a two-way system, but we will need to create a ticket either in the 311 environment or in our own data management environment.
Thank you. That's very, very good. I think you answered the question well. So, Sean, quick question for you. Is there a way for the user to know the sample size used in estimating performance measures for the data that comes in through your tool?
Yeah, we probably don't have it pulled up, but on each of those slides that Allison showed, when you look at the approach or movement level delay, split failures, travel time, all the different performance measures, right behind the actual delay result is the sample size. So INRIX, at least within the signal analytics platform, is being very transparent about sample size. And then we go so far as to, if the sample size is less than 10 for that time period that you're analyzing, we highlight it in red and we put a big asterisk next to it so that the engineer or planner knows to use some caution with that sample size if it in fact isn't large enough for the use case that they're trying to do, and to potentially consider marrying that up with a longer analysis period so that sample size can go up.
Okay, that sounds like a great step in the direction of more transparency with this data, so the user knows exactly what the sample size is behind it. Great. Let's see, maybe Ashley and Hunter, we can't forget about you guys. Presentation. So question for you. So was there any resistance to using the tool that you developed? You talked a little bit about kind of old school or new school ways of collecting data. What if any resistance was there to it, and what level of training was needed for the tool?
I guess as far as level of training, I mean, we had the iPads that we gave out to all the different workers. But I mean, iPads are pretty familiar. We're all familiar with generic websites. We try and make it very simple. It really only took maybe a couple of weeks for those guys to get used to it. As far as resistance to it, I can't say there really was.
The communications people, he met with Hunter met with all the people involved in the local government, like the communications department. They loved it. We
gave PD a login for like read-only access.
Yeah, and then I mean, like it's a lot easier to use, more intuitive than I would say the old paper system.
But I think it helped that it's Google Maps. Everybody uses Google Maps.
Yeah.
So I think everybody's seeing Google Maps. You're familiar with it. You're not, even the old school people still use Google Maps to get from place to place. Yeah. So it's kind of a familiar face.
And the Twitter is set up on the same system, so it's seamless.
Okay, good. Sounds like there wasn't too much resistance then. What are the next steps for your tool, or any future improvements coming to it?
Well, for now, the Twitter side hasn't actually really been tested. We've had a couple of rainy days, but no like major hurricanes or anything where people would be really reporting a whole lot. So we really want to get tested in that. We want to blast it out on our Facebook accounts and stuff to tell people to to use Twitter, And so we want to kind of compare results between before and after with Twitter.
How it's working in a major storm event. I mean, because that's really when you're going to see all the attention on that. I mean, like right now, we do have some days. We had a day last week where we had some roadway flooding of our major arterials and such. But it's not the same as when we have a hurricane event where we have like 24/7 news coverage and constant things going on. So that's really where we want to see that. That'll be the really proof of concept, I think, for how well it works. Though I do think that, you know, it's going forward, it's going to be integrated more and more into our reporting systems and, you know, get helpful for other items with the size of our government. I think it's definitely achievable to, now that we have this base platform for that. Like I said, the communications department really liked the idea of bringing that to our governmental systems.
Great. Thanks. We've got a few minutes left, so thanks Ashley and Hunter for those answers. And I just want to thank again all of our presenters, Kelly, Ashley, Hunter, Allison, and Sean. Great presentations. Thanks for being a part of this. And I hope you see that there's really a variety of different types of crowdsourced data out there, and they can be used for a variety of different applications. So in closing, we have a few poll questions here on kind of helping us make this webinar series better in the future. So if you don't mind answering these questions in the order that they come up. Number one, what topics would you like to see in a future upcoming adventures in crowdsourcing webinar? If you have any ideas on that, that would be great. We've got a few more webinars planned here and always looking for topics and presenters. So maybe Luana, you can bring up the next one. Hope it didn't close while someone was typing an answer. Next one, would you recommend this webinar series, scale 1 to 9? Recommend it to a friend or colleagues. Go ahead and answer that one. Thanks, Luana. We can bring up the last one here. How informative were the presentations on the scale of 1 to 5? Give us your honest feedback there. It's appreciated. Okay. Let's go ahead and close out the poll questions. 2 minutes left here, so I think I have one final slide to wrap up. Go ahead to the next slide. So just some resources that we have, it's all on our website. If you Google EDC6 crowdsourcing for operations, the website will pop up. We have a number of fact sheets, sample applications, FAQs. There's links to our Adventures in Crowdsourcing webinar series where all of our webinars are recorded. I think we've done about 15 or so now over the last few years. You can subscribe to our e-news. We send out newsletters periodically. There's a link on the website to subscribe to those new happenings and new things going on. So that's kind of our clearinghouse of information for the Crowdsourcing for Advancing Operations initiative. And finally, we want to thank you for joining us today on behalf of myself and Craig Jones and Ralph Volpe, my fellow co-leads of this EDC6 initiative. I want to thank you for joining us. And the recording of this webinar will be available in probably a few weeks. Not sure, Luana, you've got any information on that, but yeah, I see Todd, sorry, your question one closed before you finished, but thanks for putting in the chat pod. And I want to echo Luana's comment. Thanks everyone for attending today. And we hope you have a great rest of your day. Thanks, everyone.
Thanks, Jim. James, thanks, everyone.
Thanks, everyone.
Thanks.
Appreciate it.
Bye.
Thank you.